Hello and welcome to this video of engineering drawing. We are going to be dealing with lateral view and development of prisms and pyramids. So firstly, we are asked to draw the development of a pentagonal pyramid with a side base of 25 mm and an axis of 60 mm. Now, right, doing that, we are going to discover that our base is going to be a pentagon, and we are going to construct a pentagon below the XY line. So I'll just take, as we normally do, I'll just take a random horizontal line at first. So, and I'll construct my pentagon. They already told me that it is 25 mm. So I'll measure 25. So the normal method we used to use, you place your compass at the center of that line that you measured. Then you measure your 108. You know, for pentagon, it is 108. That is the interior angle. So 108 will be here. This is 100. This is 108 here. So you have it, a faint line. Then you measure another 25. After that, you take your protractor again, place it at that point, and you come and measure another 108. So this 108 here. Remember, we are constructing a pentagon. So you take the same 25. You are using, because that's the side of the base, that's why we are using 25. So we've gotten our pentagon, right? So we are now to project the XY line and get what is going to be above, get the development. So I will take my XY line to be at this point here, and from here I will get the middle of the pentagon. So how do I do that? I will measure the midpoint here, connect it to this point. I will measure the midpoint here, connect it to this point. I also do the same for this. So that will be, remember this is 25, the midpoint will be 12.5. So and that's 1.25 centimeter. That's around here. We connect it to this point here. So we are going to do the same here. Measure the middle for these two, 1.25. So, and you connect it here. So after that, I think you can actually get it. You actually get your points, because if you say you should check the midpoint here also, it's going to be around here, and you just connect it up. So I think we've gotten our points. So these are our points here. And from the question, they said there's an axis of 60 mm. That means that axis is going up here. So we have to project 60 mm upwards. In that form, we are going to be having 60 mm upwards. So 60 mm from here, you have it to be here. So mark that point. So you can just choose to do mine like this. Doesn't mean. So from here, we project all the edges upward. And before that, I want us to name it. So I can just name this A, B, C, D, and E. And let me see this point as point O. Now, let's project all the edges upward. So projecting all the edges upward to the XY line. We have this. So now, remember, this is XY line. So we have this point, we have this point, we have this point, and we also have this point. Are we together? So now we can project upwards. Project upwards to that point, to this point here. Now take a look at this pentagonal pyramid. Let's count how many sides it has. We see that it has 1, 2, 3, 4, and it's supposed to be 5. Now because of that, we are going to be taking from this point O, we are going to take another axis that will go up to that place. How do we do that? We first take an horizontal line from O outside. It can be here, it can be here, so I choose my own to be here. So after that, you take your compass and measure from OA. So when you get the measurement for OA, you will now project it. You project it to this side. You are going to be having it on here. So after that, you project that upwards to wherever it's going to stay. If it is on this side, you project it to the top also as part of the pentagon. It might be tiny, but that is the rule there. So here now, you can name this as O prime because it was this that originated to that. No, it is the center. Now we can say this is E prime here. We can say this will be A prime, then this will be B prime, then this will be C prime. Are we together? So now we want to get the slant height. The true height is going to be, the axis is 60. So let us indicate that also. Let me indicate that our height is 60. That's the normal height, 60. Then 60 millimeter. So then our slant height is what we want to use. So we want to get the slant height. The slant height is from here, from this point to this point here. So that's the slant height. It is that slant height that we use to draw the arc for our lateral view of our development. So now I can just indicate so that you are going to really get what I'm saying. This is what I'm talking about here. I'll just put SL. That's my slant height. So since I've gotten the point of my slant height here, now I will now come and start constructing my development on this side. So you take, with that same line that you took from there, you draw an arc like this. Can you see? You draw an arc. So when you draw that arc, you locate the point. This is the point here. When you locate that point, you can draw it to any, you either draw it to the last point here, draw it to the last point here. So having done that, you will come and pick your side base. Here is 25 millimeter. So you can pick 25 millimeter with your compass. Pick it with your compass. 20. So having done that, you come and start cutting from here. How many sides are we cutting? We are cutting 5 because it is pentagon. So we have to cut and be careful when you are cutting. So that is 1. This is 2. This is 3. This is 4. And this is 5. So we have 5 already. Connect those points to the apex here, and you're going to be having something like this. You're going to draw the line that are showing here. You see that it's already showing. You're going to draw a line from here. So that is the base of those triangular parts of the pentagonal prism. Please make sure it's hitting the end. It's hitting the end of the. So yes, you've done that, and what is remaining now is just to indicate the pentagon, the bottom. So how do we do that? It's very easy. We locate the center. This is the center here. Then we start projecting another pentagon. You can do that. We have done something like that before. So I'll just extend this line a bit because of my protractor for a better stable marking. And I'll come and start counting 0 to 108 here, and we mark it. You mark your 25 centimeter. And you come here again. You come and measure your 108 also again. So you measure it this way, 108. You measure your 25 also. So you come here again. The same should be 2.5. Yes, it should be 2.5. And just like that, we've gotten the development. So now that is for the pentagonal pyramid. So this is the base, and this is A prime, B prime, C prime, D prime, E prime, then A prime, because that A will meet with that one. So this is the second part of this video. So we have to draw the development of the lateral surface of the first frustum of the square pyramid on the side. So it has a base of 30 millimeter and axis of 40 millimeter. So then he said it results to rest on the horizontal plane with one of its base edges. So it's resting on the horizontal plane with one of its base edges. That is, it is a square pyramid. So that means it's a square that's on the base. So then it is parallel to the vertical plane. Then I said on that plane it is cut. A square pyramid normally, you have square below, then all the edges of the square will be joined to an apex to the top. So but now then I said it is cut by an horizontal cutting. Maybe now the way it is standing like that, you just use maybe like something like a knife to cut it at the middle. But now it is cut at an height of 20. That means from that base upwards to an height of 20 millimeter, that pyramid was cut. So when you cut, imagine when you cut that kind of pyramid, what you are going to be having, that's what we want to project. So now starting with the information they gave us, they said it has base of 30 millimeter. Let's construct that. So we're going to be having our XY line. Then we start projecting our 30 millimeter for the base. Since they said it's 30, I draw a random line and then measure 30. So that's 30. Now just project them downwards. I'm going to get a straight line downwards. I'll measure under 30. It's a square pyramid. Measure it down. Measure it down. So let me locate 30 here. Once I know my 30 here, I'll just use my T-square to round it up there. Alright, that's 30. Then my T-square finishes the work here. For a better view, let me bring the T-square downwards. Okay, so now I can just building this. We get the middle of this. We even need it now. We need to get it now, because it's that we are going to use to get the axis. So you say A, B, C, D. So when you want to get the middle of a square, you get the middle of this length here, which is 1.5 centimeter. You also get the middle here to 1.5 centimeter. And I can use my T-square to do the remaining task there. This is your angle 92. So you can see that this is the center. So you project that center upwards. You are going to be having something like this. So we measure what upwards now. We're measuring 40 because that is the axis. So we measure 40 upwards. If you measure 40 upwards, you will be here. And let me just say I broaden it a little. Now you are projecting all the edges upward, just like the way we did for the pentagon. Yes, now I can indicate it, dimension it. Let's roughly, this is 30. Yes, now it has axis of 40 millimeter. It has axis of 40 millimeter. That's from the above the XY line, axis of 40 millimeter. Let's project that upwards. So I'm projecting this upward. We have this point, then up to that apex I'm projecting all the edges I projected upwards. So I'll project it up to the apex. We have this and we have this. So now up to this place, now I can say A and D, they are in this place if you are looking at it from the front view. So I'll just say here will be A prime, at the same point also will be D prime. Imagine A being at the front and D be at the back side. So that is just it here. So I'll just say C prime and B prime here. You know, C being at the front or anyone, just know that two of them, they are at the same point. So the next thing to do now is, no, we are getting to here. We have to get where the pyramid was cut. It was cut at an height of 20, right? So now let's measure 20 upwards. Let's measure 20 upwards. Alright, so this is where the cutting plane is. So we indicate that an height of 20 millimeter, and we also indicate the full height. The full height, indicate that also, which is 40. So we can dimension it 40. So this is the point where the frustum appears from. Now from that point we project it downwards. From this point here we project it downwards to this place. Also we project it downward here, so that we can get the projection for the inner, for the top view from here. Projecting downwards here, you see that it's touching this. We actually need to make a cross section here. We will have just used that when we were projecting the center for this. So but it's not too late, you can still get it. So just make this line here, then this line here. You will see the usefulness of the lines now. The usefulness of the line is going to be that you are going to project the inner box from here. So that's the usefulness, the inner frustum. So right like that, we measure, you pinpoint your frustum, the beginning of the frustum at the top where it was cut. So 1, 2, 3, 4. And now from here we need another arc. From here, from this 0, we are going to pick from 0 to A to this place, and we're also picking from 0 to 1 to this place. So but before we do that, we're going to project an horizontal line from this point this way. So after that, we can now start from 0